I wanted to be part of a team who was changing technology towards something that people have never heard of or seen of before.
I wanted to try something new.
Wanted to achieve the unachievable.
I wanted to do something that had never been done before.
I wanted to set new standards.
I wanted to be able to leave something extraordinary behind at CAM.
I joined DDD because I wanted to produce something that hasn't been produced before.
Project Morpheus was tasked to us by the CARPA Authority in August, and it's a year-long project that spans all the way until June. What the project or the task involves is we must, as Delta Technologies, we must create a 6-kilogram polymorphic robot that can transform into different shapes, kind of like Transformers. And each configuration of the robot will perform a task of value. And so each of the morphs has a different point value assigned, and each of the tasks also has a different point value assigned. And we as a company are responsible for developing from the very beginning, from scratch, what each of these morphs and tasks are going to be.
Morphing robots is something you only really hear about in the movies. You know, it's something that very unorthodox as far as I know in engineering. And I mean, just in the fact that this project was taking everyone in EDD way outside of the box was something that really appealed to me.
It forces us to think outside the box because we have to handle everything literally from the ground up. We have to come up with a concept from scratch, something that we've never done before, research it, and make that function properly.
One of the hardest parts that I think we had as a team was actually coming up with our final design. I know we were deliberating till the very last moment. I think we left 3 weeks or something to actually create our entire POC document, as well as create our presentation. It's very difficult when you have 17 people with a lot of differing opinions, most of which are entirely valid. So there's a lot of arguments that have to go into this kind of thing. It's very important that you come up with something everyone actually really likes, because when it's something everyone actually likes and is excited about and wants to create, it makes it a lot easier to motivate them to contribute and be a big part of the project. And it's important that everyone gets to do something extraordinary. At least that seems to be the motto of this class, is to do something extraordinary. So.
So right now we have 4 options for our morphs, and the tasks would be.
The strategy of this year's team was to push our current engineering capabilities to the limit. We decided to do that through a very, very difficult task of being able to do autonomous flying, as well as other sensor readings, along with 3D room mapping.
Flight would be recon, right?
Yes.
Yep.
Drive would be.
Could we pull up the survey?
So originally we set out our goals of what we wanted to do, what we wanted the robot to do, but then we went into designing how essentially wanted to approach those, and we went through many different designs in order to get there, like going through water, going through air, and all these different possibilities, but just deciding on how we want to do it and why we wanted this instead of some other method. It was just a very long process and very difficult to actually set what we wanted to do.
Okay, so the first thing I noticed is this detachable payload seems to be the source of all of our problems.
Or most of our problems.
Because all of this stemmed from having this detachable payload.
The biggest problem was that we spent a lot of time on our first design trying to choose between detaching and not detaching.
And the reason the design doesn't fit morphs is because it has a payload that detaches. Now I hear you guys, and I understand. The original design might not work because of the weight constraint. We planned it out. And you guys, we did the math, and it's like, there's a good chance it won't work. But have we really exhausted all possibilities of it? Have we really designed to the fullest extent to see where can we cut every kilogram, every gram we possibly can to maybe get a design that'll work without the detachable payload?
One of the troubles we came up with was that so many of us came up with so many designs that it was very difficult to choose from, and that pushed us back and the time schedule that we had, and just procrastination between choosing a design was a really big issue for us.
What I see what we're doing now is just adding a couple of new things that might not be relevant to what we're trying to complete in that form. And the only reason why we would try to morph complicatedly is to try to complete a task more efficiently through that morph.
The wheel is touching the ground past the treads, and then if you rotate it out, then the treads are on the ground. So to be able to go from drive to flight to another drive state is very unique and different from any other robot I've seen. In the end, we decided to use a Y6 configuration. We picked the Y6 because we wanted to try something quite extraordinary as to lifting a 6-kilogram robot, which under the circumstances is actually very, very difficult due to the size constraints provided onto our rotors because of the shroud. It made it very difficult to be able to provide enough lift to be able to fly this robot stably and so it could be controlled. Well, it's close to straight.
Testing the robot was very tricky because we had different subsystems, but what we did is that we separated into different teams, and each team designed its own test for the robot. So, for example, in the aerial reconnaissance unit, the team designed a test to actually see if the robot can lift a certain amount of grams, or actually if the robot can even fly.
On top of the motor.
Go.
Michael, go.
Okay, so during the research and development portion of our project, we were deciding how we were going to sense minds. To do this, we decided to use a device called a geophone. It works by sensing vibrations coming from around it and coming to it to kind of understand the intensity of the vibrations and where it's coming from. One of the problems that we faced was how to interface this with our robotic design. To kind of help with this, I researched about how the geophones worked and under what circumstances they could be used. To do this, I contacted a University of Mississippi professor. His name was Dr. Sabatier. He was a great help because he called a lot, emailed, told us what was going wrong, how to fix it, and the kind of things that we could use to make the system work. He even went so far as to purchase our geophone kit in order to run his own tests to help us better prepare for our challenge.
So the slide's too slow, the one that you edited.
No way!
Back.
No, he had a loop on it, so it'll fix it. What? It's going straight.
We tested a drive by placing the robot on the ground and seeing how far and how fast it would travel. However, the robot did stall occasionally, but we were able to sort that out, and in the end, the robot ran just fine.
That first day, when we said that we were going to do it, we've done it pretty much. Advanced this class, you guys have done a better job than pretty much any other class before you. I'm really proud of that. No matter what happens today, no matter how this turns out, I'm extremely proud of each and every one of you for the effort that you put in, for the dedication that you've shown. You have done what I don't believe any other high school in the country has done. And I want you to be proud of that, and I want you to showcase it today. Okay? So, do it. All right?
Make sure that we can get everything that we can get done in class, use of the machines, use of the mills, printing, whatever is done in class. And at home it's more like chatting and whatnot. So we keep a lot of our class times and class discussions when we meet everything. We really figured out how to make meetings run smoothly and get the biggest work out of our time. This is Eric Johnson is our most avid documenter. We have 2 engineers notebooks from him. Yeah.
He takes notes of everything. We also do that, but it's going through the technical data package, and this includes basically everything that you need to build our robot. So you can take this and fabricate it.
And this is drawn to actual industry standard ASME Y14.5. We spent a lot of time on that.
I learned that teamwork is essential in order to get a huge task like this done.
I've learned many things in this class. One of them was the engineering aspects, actually how to design, how to use machines, how to use Mastercam, and learning how to use Autodesk and Mercury again. I mean, that was a struggle for me because I forgot, but it was fun learning like the entire process. But I think the most important thing I learned was working with the team, being able to communicate your ideas with others and how to express them.
As a software engineer at Delta Tech, I learned certain programming from the head engineer or head programming engineer, and also how to work as a team.
I learned how to manage people with different skill sets, providing mentorship for those who didn't know as much as others, and implementing them into creating a design that everybody on the team agreed with.
I learned to be faithful with that which exists within yourself.